welcome to the Southwest Regional Transfusion Committee's Transfusion Matters Education event. So this event is aimed at BMSs with under 2 years worth of transfusion practice or returning to transfusion practice. We've got some wonderful presenters here for you today. Tim, I'm a transfusion lab manager from North Bristol. He is an extremely experienced blood bank manager in a busy trauma centre in North Bristol. He has co-authored and been acknowledged in a number of transfusion articles, journals and posters. He's a member of the National Transfusion Lab Managers Group, and he's often seen presenting on a variety of transfusion-based subjects, both locally and nationally, and is forever volunteering his department for various national transfusion improvement projects. He is passionate about transfusion science, BMS empowerment, and is a genuinely all-round good egg.
Welcome everybody, thank you for joining. I'm presenting on the ABO Group Anomalies. It is actually more from a hospital transfusion laboratory aspect rather than the RCI side of things. They've got a lot more wonderful sort of testing they can do. So a little quick introduction, a recap. So 4 basic ABO phenotypes, which are O, A, B, and AB. And from the guidelines, the pre-transfusion procedures in blood transfusion laboratory 2012, I highly recommend you read those guidelines. There's plenty of good information on that. And one of the things that sort of really sticks out when you read those is that the statement, the ABO grouping is the single most important serological test performed on pre-transfusion samples, and the sensitivity and security of testing systems must not be compromised. That's one of the big things we do. So that's a very sort of solid and important statement. So we have 4 groups. So these are looking at the antigens. They're expressed as early as 5 to 6 weeks gestation. And that's the ABO ones, of course, I'm talking about. And then we got a reverse group. These are antibodies against whichever ABO group so you are lacking on your red cells. They're usually formed by about 4 months, usually from sort of maybe bacteria in your gut and things like that from exposure. So what can cause problems when we're in the lab grouping these samples? So first of all, we've got our technical side of things. I'll go through that in a bit. Serological, and it can affect the whole group, or it could affect just the forward group or the reverse group. So I'm going to sort of break that down a little bit and just talk through some of the things we may see, and then talk about what we can do in the lab. So first of all is sample. On the top of the list is a phlebotomy wrong blood in tube. So you may have a history, you get the group, and it's completely different. So the first thing is, this is not something about other things we might see in forward reverse group. This is where the blood group just does not match the historical group. So therefore, first of all, we think of is is the right patient that has the sample labeled correctly? Is it that sample, or is it the sample that was taken before? When we've had that before, where the blood group is changed, we investigate and we realize actually it was a sample from 3 years ago that was actually wrong. We only had the one sample back in that day. So it's important to look at those. You then have lab error, and the way you look at that would be to repeat your sample and make sure you explain that, take it from that person, check and check again. Lab errors. So, you might have the sample, it's labeled completely fine, the form and the sample is taken from the right person, but in the lab, we've now somehow labeled it with the wrong patients. So you might be booking in a couple of samples. You might be, I would not advocate this way. You might book in 10 samples and label them afterwards. We always just book in 1 sample at a time. But if you have done that, or you've picked up the wrong sample when the label comes out and you put it back on, you might put it on the wrong sample. So you've got the label in there of the wrong patient. Or you may pick up the wrong sample. You ask to do a group, you pick up a sample, you presume that's the sample, you haven't done a proper check of it, you just do the tests, and you get the wrong result. So that's the lab errors for sort of booking in and processing. Then you've got reagents and samples. Have we chosen the correct reagent? Have we missed a reagent? So if you don't put in an anti-sera, it's going to look negative. Is it contaminated? We had a case where the group just didn't match. It didn't add up with the first group for a group. And you can see all sorts of weird and wonderful stuff. And it turns out some anti-B had splashed into the anti-N. It's really quite strong anti-sera, so it doesn't take much to start affecting results. Have your reagents expired? So this is all good sort of laboratory practice, checking, recording, just making sure, if you never presume that what you've pulled out the rack or the sample you've picked up is a sample you're expected to be. Always make sure that it is what you think and expect it to be. So check the samples. When you pick one up, you check the labeling. Some processes, you're booking in, you check it there. You may have another check-in process when you're what we call verifying the sample, and then you may check it again, authorization, or certainly check it when you are performing manual tests and things like that on it. The integrity also comes into it. Was it sufficient? The blood groups might be funny, not getting the reverse group you expect. Is it sufficient? Has it not pipetted out, or have you not put in the plasma? Hemolyzed or lipemic can affect the results as well, which it just fools the analyzer or just interferes with the sort of testing we're doing. Check the reagents. If in test tube, again, not everyone does this anymore, but we certainly we have a place for it. Put out your anti-serum first and your plasma first. Then you can have a quick look at it, and you can see, oh yes, I've got plasma in there, I've got anti-serum in there, because you can see that once you put the red cells in, it's not as easy to tell because red cells are red. And if you got a bit yellow, put a bit red in, it still looks red. So you check that, a little check of that, put your red cells in, and that's a good little check doing. Cards, check the presence of red cells. It sounds simple. I mean, don't forget the simple stuff is really one of the things I really want to sort of drum home today. Don't go diving into the air and the mystical side of things of transfusion. Start the basics, start the little stuff. So check the red cells are in there. Check the levels after centrifugation of the reverse group. For instance, you've put your A1 and B cells in, and you've put your plasma in. It should come to a level. If it's below that level, it indicates that maybe you did actually forget to put the plasma in. We're all human; these things happen. Usually, distraction is the key there. And if you find anything wrong, then you can sort of carry on. Automation. Check for alerts. Visually inspect the results, because you might get a result that's come out of the analyzer, but go and have a look at them, because it might be telling you something else. Check the QC as it passed. Is there something wrong with the analyzer, for instance? Maybe bleach or something still in the line, destroying certain things. This is another interesting one. We normally use EDTA. So EDTA sort of deactivates complement, along with a few other things. So with serum, you may get the C3D, and that can cause hemolysis, certainly in the reverse group. Some I used to see as a young BMS, but we've all moved to EDTA, so we don't normally see that so much in the labs. So one of the things you can do, start off when you see these sort of issues, is repeat the test. And you can also, if you're still not getting anywhere, or you think something wrong with the sample, etc., maybe it's hemolyzed full stop anyway. Forget about complement and stuff I talked about. But you may just have it hemolyzed from the phlebotomy process. Request a repeat and a new sample. I'll put EDTA in just there, but I don't know how many people actually still use serum samples. Not many, not since automation. So let's go on to the reverse group. This is probably the most likely sort of anomaly you're going to come across in the lab. So first of all, let's talk about when the result's negative, but you're expecting it to be positive. So for instance, if you're O, you expect to be positive anti-A cells and the not anti-A cells, and the A cells and the B cells. If you're A, you expect to be positive in the B cells, and if you're B, you expect to be positive in the A cells, and if you're AB, you expect to be negative. So if you're expecting it to have a positive reaction in one or either of the red cells, but it comes up negative, what do you do? So first of all, could be technical reasons. All the things I talked about before, is the have you put the cells in, have you put the plasma in, those sort of things. Then the most obvious one, thing that hopefully everyone sort of knows about, is the age. So if you're young, we don't normally start producing those until about sort of 4 months. We do see them earlier than that. I know quite a few hospitals that actually do reverse group on babies, and they say they sometimes detect anti-A and anti-B. And then you get old. As you get older, they start to produce. You can see it in malignancies, CLL, lymphoma, myelomas have those sort of problems with the reverse group. Immunosuppression, example, if you have had a post-stem cell transplant, again, that's when you might start seeing the suppression or the lack of reverse group. And again, hemolyzed may be interpreted as negative. Hopefully, analyzers these days don't really get fooled by hemolyzed samples anymore. They're normally good at picking them up. And then if you do by eye, hopefully you'll see that as well. But that's one of the things, you might say, oh, I'm not seeing, well, yeah, you probably won't see any sort of button at the bottom. So what do we do? So first thing, make sure the plasma's added and the correct sample tested. Some labs may separate the plasma off, and if you separate it off and it gets mixed up, you might be testing someone else's plasma. So that's again the technical side of things. So make sure that you've added the plasma as the correct sample. Check patients in history. Have we seen them before? Is this something we've tested before and we know the answer already, and we can just repeat that? The old classic is obviously incubate at 4 degrees for about 15 minutes. The anti-A and anti-B do like to work at those conditions. That's some of the favourites, like 4 to 18 degrees is like the optimal condition. So you can sometimes enhance that reactivity. Increase the amount of patient plasma. For instance, if you're doing it tube, a couple of extra drops of plasma just to enhance the amount of antibodies that are going to be available for the red cells. Maybe add a little more to the cards. Of course, you're going off piece a little bit there with the manual side of things. So hopefully it's been verified and validated. But that's one of the things you can do. Add in a little bit extra plasma. And if you can't get any resolution with the reverse group, one of the things in the guidelines, it says perform additional forward group, ideally different method or reagents. Certainly with babies, you might want to do it twice. Go, right, okay, that's A, do it again. It's still A. Okay, good. We'll report it as A. And again, repeat sampling ETA, which is probably what you have anyway. Then you've got the other side of things. What if it's positive when you expect to be negative? This way it gets a little bit more interesting. Again, check all the technical reasons as before, reagents, etc., etc. Then you have things like subtypes. So, for instance, an A2 with an anti-A1 is quite a, what did I say, common. It's certainly someone we will certainly experience. So one of the things we'll do there. Actually, no, I'll tell you what we're doing in a minute. Then you've got other subtypes, A3, B3, etc. But they are quite rare. I've never seen one. Then you've got cold agglutinin. IgM anti-M is a classic. If the reverse cells are M positive, you may suddenly find that you're getting positivity when you are not expecting it. And usually IgM obviously works sort of directly, and therefore you can pick it up. Then you have the rarer anti-HI. Again, you don't normally see it as much in the reverse group. You'll see it more likely to be detected in the 3-cell screen. And the reason for that is H1 cells have a lot less H antigen on them. H is obviously the building block. You have to have H to make, A, your B with all your fructose and your transferases and all that sort of thing. So A1 cells have less of as much, whereas O and A2 or A2B patients who have a lot more H, that's why you'll pick it up in the 3-cell screen. It'll probably be pan across the board, same with the screen and the panels. I was going to say, well, what pattern would it be? I've just told you, it'd be pan, it'd be everything. Now the auto should be negative, so that's a bit of a clue. So with those patients, you certainly don't want to issue O, which is what we're talking about a bit later, what we'll do these sort of things, because O's got a lot of H on, so you're better off to cross-match against the patient's cells using maybe A2 if you can. Then you've got your bone marrow transplant and stem cell transplant. I remember a case back in the day. We had someone coming in for theatres, and the forward group was A, or was it B? I can't remember which one, but the reverse group was coming up positive in the A1 cells and the B cells. And we were doing all these tests. I couldn't figure out. I said, this looks genuine. So I rang up this and said, look, something going on here. What's the history? I mean, sort of thing we see this is so maybe a bone marrow transplant. She goes, oh yeah, the patient had a bone marrow transplant, year before last. I was thinking, thanks for letting us know. So because it was coming in for pre-op or operation, that's what the operation was for. They failed to realise that telling us that it had a bone marrow transplant was quite important for us to know. So how do we get around this? So again, we check correct reagents used, check patient history as we're talking about. You can check spice as well. Hopefully everyone knows about spice. It's NHSBT's record, RCI's record of all the patients that may have been seen. The trust has to send a CalDIGOT agreement to allow that to be shared. And if the trust hasn't done that, you can still see reports there. You just can't see those reports. At least you can ring up RCI and ask them about it, and they're happy to tell you what they may have found. And so we'll tell you what sort of investigation we carried out before. Check if they're a bone marrow transplant, as I said before, my experience of that. The other thing is you can incubate at a higher temperature. That can sometimes resolve the sort of the cold side of things. And if you do suspect a cold acting antibody, one of the things you can do is a room temperature of 4°3 Celsius screen/panel. That can sometimes show up and say, oh, there's anti-M there, for instance. So we see quite a bit of. You can also select cells negative for the antigens, such as if it's M negative. Again, it's just, they're not going to be validated reagents if you haven't got those sort of things, but that's the sort of thing you can look at. If you suspect it might be an anti-A1, you can type for anti-A1, and if they're negative for A1, then you think, okay, they're A2, probably with an anti-A1. You don't know that for certain, but it's a good, so we're looking for a good assumption as such, and basically what you're going to be cross-match compatible anyway. So if it's compatible in a cross-match, it's going to be fine. The other thing to think about is, do we need to refer to RCI? Again, you only want to refer to RCI what you really can't resolve and what you can't sort of get a cross transfusion strategy for. But yeah, they will do extra help, and that's probably a good place to plug the RCI. Was it Assist? There's a nice program NHSBT have which really guides you through the process and stuff. Highly recommend that. If you haven't seen it, get a look at that. Maybe we can post a link to it, maybe in the chat or something, Carol. So yeah, forward group. So this gets a little bit more sort of tricky sometimes trying to resolve it. So again, check the sample reagent stuff we talked about already. You may have weak expression of the A or B antigens due to malignancy, or you may just have a weak expression due to A or B variants. One of the most common things we're most likely to see is going to be mixed field. Mixed field is when you see like dual population, you can see sub-agglutination, you see sort of free cells as well. In the card, you've got top and bottom, and you go, okay, it's nice and easy to see in that. So usually it's from mismatched or incompatible transfusions. So that can be emergency blood or substitutions. So for instance, if you have, let's say, take RO, a patient who could do with some RO, they haven't got any, so we give D negative. The other thing is, of course, don't forget to think about, has the wrong blood been given? There was a case, can't remember what's now, quite a few years ago, reported in Charlotte, where I think it was an O patient had been given A or AB red cells. They were grouped in the mixed field. They went, okay, yes, it's because we've given them O, and they carried on giving A or AB. I can't remember which one it was. Luckily, I don't know how, but the patient didn't actually react too much to it. But the point was that the error that was made at the beginning gave them mixed field, and they made the assumption that then no one had done that. Therefore, we're carrying on with the A's. Intravenous transfusion is another one, because we will transfuse most likely to going to be the O red cells. Bone marrow transplants, we talked before. You start seeing a difference. You might see sort of mixed field in that as well. Large FMH. So again, if you've got a mum who's had a large sort of fetal maternal hemorrhage, they've got a lot of fetal cells floating around, you may start to see the mixed field in those cases as well. Babies, twin-to-twin transfusions. So that's where one twin's blood goes into the other twin. It's not the same blood group. You then get your mixed field. And you've got the really rare stuff like the chimeras and things like that. So what do we do to resolve this? This is a little bit sort of tougher to resolve in a way. So first of all, check the correct sample has been tested. Check patient history, bone marrow transplant, transfusions, etc. Check correct reagents are used. Repeat the test. And then if still on problems, maybe repeat the sample as well. And then if you still can't get anywhere with that, refer to RCI for if still unexplained. Again, I'm not going to be talking about the sort of things they may do, but maybe that's another topic for the future. Okay. Now, I know it says ABO, but I couldn't possibly go by without talking D-typing. We do D-type with it. So things you might see is weak D. You might see different reaction strengths between the two D-type reagents used, and that could be a variant D. We also see pregnancy, where at booking, the D negative, but by the time we get to 28 weeks, the D positive all of a sudden. And that's because in pregnancy, you start expressing the D antigen a little bit more. So it's weak, and then just express more enough to pick it up at 28 weeks. So what we can do, you can do IgG weak IAT testing. However, that comes with caution. If you've got a positive DAT, it's going to give you false positives. So they don't recommend that. In the guidelines, don't recommend it. So you have to be really sort of strict criteria, check-in, etc. before you actually report the result on that. Again, refer to RCI. We send quite a lot of like weak and sort of possible variants to RCI. I haven't got the resources to do that in the lab. So reporting, if a reverse group due to age, using two groups and report, take into account local SOPs and policies. Just because I've said it on here, don't go and start doing stuff in your lab, run past lab managers and things like that. If no history and due to recent transfusion of non-identical, how do we report that? Query D positive, negative. If that, if the mixed field is in the ABO, was it A, B, or O? Query, or unidentifiable if it's mixed field across the way. In those situations, you want to give group O red cells A high titer negative plasma platelets. D-typing. Just have a quick check of my time. Ooh. Okay, so female or childbearing potential, you need to treat as D negative. So therefore, you offer prophylactic anti-D and get D negative units, and then you can wait until RCI confirmation, and that might include they are partial D, treat as D negative, or I might say they're weak D, treat as D positive. Once you've got that, you can then put that result in and treat them as such. Guidelines state that males or women over 50 who are not likely to require long-term transfusion can be treated as D positive without confirmation. Okay, that'll be down to your local policies. Now, I put this from the guidelines. I'm not going to go through it. I just want you to be aware of it. It's a nice flowchart that sort of talks you through the anomalies, the things you might find, what to do to resolve it, etc., etc. So jump on the guidelines, have a look at that. So here's my first case. Now you need to jump into the chat. I've got monitor over here, so I want to look up. I'm just looking to see those. Right then, who wants to have a go at telling me what is going on here? I'm going to give you a few seconds, so you have to type fast. I should have given you like a choice, maybe A, B, or C. Anybody want to have a guess at that? Probably caught people on the hop here a little bit, so probably not fair of me. Okay. Yeah, I think it was unfair to ask people to type in. It's going to be a little bit. Okay, here we go. Whatever servers, the lab. I think. Okay, so you've ruled out issuing. So the lab. Then I'm thinking long blood in tube, unlikely contamination at the time of taking sample. Could ask antenatal location. Who are
Sorry, Tim, that was my answer to an earlier question I was typing in there, not for this one on the screen. Sorry.
In which case, I'm just going to go straight into this one then. Right,
sorry.
So what we see here is we've got mixed field. You can see the mixed field. What's interesting, though, in the anti-B, you can see you got plenty at the top, anti-D, you got some at the top, and you can see a little bit at the bottom. But you can see a lot more in the B. So we've only got mixed field. Look at the reverse group. So we got positivity in the A cells and you got negativity in the B cells, which indicates from the reverse group, look at the reverse group, it looks like they are a B patient. We look at the forward group, we got negative in the A, which again indicates they are not A, but we got mixed field in the B, indicating that some of the cells are B and some of the cells are not B. Then you got the D. You've got a lot less at the bottom. And you notice in the B, you got sort of 50-50. So what this is a patient, a B patient that has been given O negative blood. And there's only a small amount of I think what's happened there is some of the D negatives have come through, but I think some of the D negatives are probably caught in the top as well. So you've got the D positive that's caused such a mess up there. I think it's actually holding some of the D negative cells through as well. The one below is capture. So again, this is just the two technologies sort of mostly out there. You've got card and capture. And the analyzer for capture has called this a straightforward OPOS. But if you look at the reaction here, you can see some reactivity in the anti-B. And the measured value 25 indicates there is presence there. And this is actually the same patient. So you can tell the difference between capture and card. Card, you see mixed fields so much better. Okay. So if group of transfused RBC is known, e.g. O neg, can we change the group we can see behind it? So that's a good question. How do you report that? So one big question is, do we report it as O to be safe? I'm just having a quick look at the time. Okay, we're doing all right. Some limb system force you to have a report a blood group. So can't release blood unless you put a blood group in. So you think, right, okay, we're going to put O in because that's the safest red cells to give. So they put O in. Ideally, you want to be able to put in query D positive neg or ABO query or a total uninterpretable. And then you still have to give the O red cells, give you A plasma, A platelets, etc. We are expecting more guidance to come out on how to report these because there are issues. Let me tell you about a case not too long ago. Organ donation. So that's that mixed field. The limb system will not allow them to put in a non-group like we can sometimes type in sort of free text. So makes sense. Let's call them O. They called them O. This patient unfortunately didn't make it, but they were going to become an organ donation. So when they asked what's the blood group, they looked on the limb system, they looked on the PAS system, and they found out the patient group was reported as O. So they gave those organs to an O recipient, an O patient. This organ was rejected because the donor was actually A. So that's why his guidance coming out how to report that, because without a blood group, they will not want to take the organs to transplant them. And it's a big waste of organs if you can, and we can't do it. And we have the same problem. And what are they going to do? So they will try and force you to put in a blood group. And as you see, it's not always easy to do that. Case 2. Right. Antenatal group of booking and 28 weeks was BD negative. The free feed today wasn't taken for whatever reason. Patient declines routine and prophylactic anti-D, stating that she knows she's B positive. We've got no record other than O negative on our limb system. There's no record on spice. What could be going on? I've got a few minutes, so I'm not going to ask for any typing on this. So let me tell you that actually they're both correct. So this is a case we had. I've seen it probably about half a dozen times, maybe a dozen times, where people say, "No, I'm confused. My blood group is D positive, O positive, etc." And actually both correct. So basically, it turns out that this patient was a blood donor, and it turns out there are variant 6. So when you donate, you check, the NHSBT check to see for variant 6 because they want to call them positive. You only want to give them to D positive patients. However, as a blood bank, we don't want to call them D positive because we don't want to give them D positive blood where they can make antibodies against the part of the D they don't have. So we want to call them D negative as a recipient. So that turns out we're both right. So it's something to bear in mind. I've come across it a few times like that. Okay, I'm going to talk about acquired B very, very quickly. I'm not going to mention it really. So basically, patients can acquire the B antigen during necrotizing infections, during which bacteria release an enzyme into circulation that converts the A1 antigen to a B-like antigen. We don't really have this issue. This came out, I think, probably in the early 2000s, and the recommendation to change the reagents so we pick up this. But it used to be a problem. Now, why am I telling you about it? It's a history lesson. But the other thing, the beautiful thing about being a biomedical scientist, it opens so many doors. You can work abroad and things like that. And abroad, they may not have those reagents, etc. So that's why I mention it as a historical thing to be aware of. Now, could I possibly finish without talking about Bombay? I'm going to go through it super quick. We're not really going to pick up on it, to be fair, in the grouping. It's a rare condition, one in 10,000 in India, 1 in a million in European assets. I think globally it's 1 in 4 million. results from a mutation of the FUT1 genes. Got to be careful to say that. And that's what produced the H antigen. As we know, H is essential for making the A and B antigens. So they appear as group O, and as standard, they'll have anti-A, anti-B, but they'll also have anti-H, which means they are very, very, very difficult to transfuse. And like I say, you're going to discover more in the 3 cell screen, the pounds, because they're all O and have a lot of H. So it's going to be pan across the way. And again, they can only have blood from other Bombay donors. I've never seen anyone with Bombay, but you might one day. But like I say, grouping wise, they're going to look like normal O. Reference I talked about comparative procedures. Do read them through. I think they're being updated and hopefully be out soon. But I do like these guidelines. There's some good information on that. I just want to say thank you. Any questions? Could be technology. Depends which technology you're using. It could be you've taken sample briefs and you've tested all those. It could be, I mean, sometimes I've activated samples, we've got fibre in, which could sort of look positive. You can always see that they do look different. But that's another possibility. Like you mentioned before, it could be a completely wrong patient. And if it is a wrong patient, you're worrying, who is that then with the positive antibody screen? And that's always one of the things that worry me when I get those sort of reactions and stuff. It's difficult, isn't it, when you go, oh right, I suddenly changed negative. But that would indicate more of a sample integrity kind of thing, I think, or wrong blood input tube.
It wasn't panelled and 2 samples were negative, I'm assuming, afterwards. So, and sometimes pregnant women chuck up stuff, don't they, as well, in antibody panels?
Yeah, I just wanted to can you hear me?
Yes.
Yeah, I just wanted to mention, so I not long ago I saw that kind of scenario, but it wasn't a pregnant patient. So we had like a positive antibody screen, which was accepted off the analyzer. However, the second BMS came in and did the paneling, and it was like, it didn't make sense. So he looked at the sample, and the sample was not spun. So when he spun it down and then repeated it, and the antibody screen came up negative. So that, I don't know, maybe that would contribute to it. I don't know, but that was
yes, definitely.
Such a great point.
No, absolutely, very good spot on that as well. Yes, I mean, like sort of like even like little platelets in there can actually start affecting it, sort of things. And if you're getting more red cells and stuff in there as well, that will probably affect it. But yes, I imagine it probably be sort of the platelets and things like that. So that's a very good example of technical something which I didn't mention. So thank you.
But you did say early in your presentation, Tim, keep it simple. Always rule out the simplest things first of all.
I was going to say that too as well, Tim. I think it's so easy as a scientist to jump to potential for something very complicated and exciting, but 99 times out of 100 it is the boring basics, such as someone has taken the wrong sample from the patient, or there's been splashed over in the processing if it's a manual technique. So I think of it like a ladder. Start at the bottom and try and rule out the obvious things first before you then jump into the weird and wonderful.